Hello everyone, my name is Smit Mehta and today I am going to present my Studio 3 work which is from the semester 3 of my Masters in Construction Engineering and Management at CEPT University. So for my Studio 3, we have taken the residential tower project in Integrated Construction Practices Studio. So let's talk about project brief. So this project is located in a gift city and having a plot area of 5128 meters square. There is total number of units are 496. This project is having the floors of 33 typical floors with basement 1, 2 and 3, for which this is the project type is greenfield project and building height is 140 meter. This project is having two towers A and B which have six connecting bridges. This project have timeline of starting from the 10th January 2023 to ending on 9th April 2025. For this project, I am having taken the roles and responsibility of contractor and plumbing consultant. For the different roles and responsibility, the same team has worked on. I have taken the construction management to prepare and execution of the site layout mobilization plan and optimization of the site layout, ensuring the adherence to the project schedules and budgets with the development of 4D and 5D simulations, cost estimations and quantity takeoff, integration of all disciplines, ICP process mapping, and plumbing system design, for which preparation of LOD 300 model for the plumbing elements. LOD is the level of design and integration of all disciplines. This is the Studio 3. The scope of work is typical floor tower A. Estimated project cost is 150 crores, for which shell and core cost is 80%, which is the highest, and total cost of the project is 121 crore, including mean core and shell cost. So for residential tower, this is the plumbing model, for which we have done the plumbing model process mapping, in which the process starts with the LOD 400 architectural drawing and structural drawing sets. After getting the structural drawing sets, we have taken the input of LOD 300 structure and architectural model, designing elements for the plumbing and fire safety, modeling till LOD 300 for the different services, sharing model on a beam 360, then doing clash detections. If they found any kind of clashes, we have done the clash resolution process and updation and modification of MEPF consultant roles, sharing model with beam 360, and then previous clash detection reports for the coordination and team will be also checked. And after ending the process, we got the LOD 300 model and clash free LOD 300 model. So this is showing the plumbing LOD 300 model with 32 dia PVC domestic water supply pipe, PVC hot water supply pipe, PVC flushing water pipe, PVC 50 dia pipe, and PVC 110 dia pipe with different usage of water supply in a washing area as well as use area for the plumbing model. So as a part of site layout modeling and site layout optimization, this is the model for the current site layout, which is consisting of induction room, punching room, PMC office near entry 1, parking congestion issue, which is we can see in a 3D model, and unprotected steel storage as well as disorganized scrapyard near site gate 2 and gate 1. So for the gate 1, we have done the path of travel analysis for the current site layout, for which the speed is 1.34 meter per second and length we got from the Revit after calculating path of travel, which is 118.433, for which the current time is 88.38 seconds. Same for the induction room to gate 1, which is 480 48.5797 length, where current time is 36.25. Or same for the PMC office to drinking water point. The speed is 1.34 meter per second, length is 76.9724 meter length, and current time is 57.44. So in optimized site layout, the path of travel of the optimized site layout, where we have enhanced the site with covered steel yard, organized material yard, which we have provided nearby gate 1. Same for the drinking point added near the PMC office along with the induction room. And we have provided new punching room near gate 2, which is in a earlier uh, current site layout, which is at gate 1 and inside the nearby the office, PMC office. So path of travel, which we have enhanced the length of a punching room to gate 2, which is 9.7253 meter, and time is now very reduced to 7.26 seconds. Same for the induction room to gate 1, which is also reduced with 28 meter, and time is reduced up to 21 seconds. from the PMC office to drinking water point, new water point is added. So that's why new length is 4.42 meter, where the current time is 3 seconds for the drinking water point to PMC office. And we have also enhanced the site with the dedicated parking space and also given a new safety park area for the site, which is not there on site in a current site layout. So as we can see, the site layout analysis for the reduced punching room to gate 2 distance, which is earlier 118.43, is reduced up to 9.73. Same for the induction room to gate 2 distance, which is reduced completely from the 48 meter to 28.71 meter. And same for the PMC office to drinking water point, which is 76.97 meter, is now 4.43 meter. So for same for that, the path of travel analysis of time, which is seconds, which is reduced 88.36 to 7.26. Induction room to gate 1 is 36.25 seconds, which is reduced up to 21.42 seconds. And PM office to drinking water point, which is 57.44 seconds, it reduced now to 3.3 seconds. So implications are increased productivity, reduced fatigue, and cost saving. So, inference we got from this is path of travel analysis reveals notable implications on a site efficiency, optimized routes, reduced travel distance, and time across the key locations, directly enhancing productivity by minimizing the time workers spend move between areas. So, it is better to have a nearby locations and drinking water points for the workers and as well as the team, which we reduce the unneeded waste of the time on a site. So for the residential tower, this is the 4D use case we have taken and done using the Synchro. The 4D simulation aligns with the LPS implementations, providing a detailed visual tracking of a task over a specified time frame, which aids the microplanning, productivity tracking, and efficient resource management on site. The problem statement here is all the contractor has access to 3D model integrated with all the service of Navisworks. The project team lacks the necessary training and tools to explore the model effectively. As the result, valuable asset remains unused, limiting the team's ability to leverage the model enhanced planning and coordination. So we have approach for this, and which is the 4D simulation has been implemented. A practical approach supports on-site last planner system coordinated for the 6-week period. This simulation enables the real-time visualization of construction progress and reduce the allocation of sequencing. So the scope of work is construction activity levels from the 18 to 21 tower A, which focuses on a formwork, reinforcement installation and RCC work for a slab and a beam post. Also, LPS implementation duration is from the 1st of December 2024, 1st of October 2024 to 1st of November 11th of November 2024. Moreover, the 4D simulation exploring construction complexity of the steel bridge or construction connecting two towers of A and B building resourceful from the beam use case on site for the officials before they start the execution of work. So, in this, we have approached the process for the 4D use case is assigning the pore IDs to the component in Revit and export the SPX file, which is Synchro file, assigning pore IDs to activities in MSP schedule, importing a Synchro file into schedule and adding the schedule in Synchro, assigning components and auto match rule, set appearances, profiling and assigning the activities, then set the baseline and give the actual dates to activities, run the simulation for the planned and actual date, set the baseline and give the actual dates to activities, run the final simulation, and in which we got the for the outcome we are getting the XML file for the schedule, MP4 file for the simulation, and structural model 300 structural 300 model. This is the 4D use case for which the problem statement is earlier stated that constructing six recruiting steel bridges to connect Tower A and Tower B. Each bridge span is 101 square meter with high section metal deck slab and cross bracings. Positions 1500 mm below the slab level, requiring soil compaction and landscaping on the pathways. Challenges in aligning steel components and coordinating with the future landscaping. Approach is developed a 4D simulating a Navisworks and a Synchro 4D Pro model. A micro schedule outlining construction sequence of I-section deck slab and cross bracings. Visualization helping the engineers to anticipate issues and improve the on-site execution planning. The for process we followed as the simulation underwent several iteration for the accurating positioning and connection of orientation of steel components. Unique identifiers were added to key activities like installation, order, and steel members and decking placement. Soil compaction plans at the 1500 mm depth aligned with the landscaping and requirements. Site engineers review the simulation and discussing the sequencing for the strategies to reduce the rework and risk and enhance the construction efficiency. Use case on-site construction flow process. Erection of main member, erection of secondary member, pressing of metal deck slab, and then placing of the cross facings. This is the 4D visualization which we are getting after the adding all the resources to and assigning it, doing auto matching with the pore IDs of the Revit, and then doing it with the Mehta. 5D model. According to RIBA plan of work, the 5D simulation refers to the BIM process that integrates the cost data with the 3D model, allowing the stakeholders to visualize and analyze both the design and associated financial impacts on the real time. So, process here which we have followed is the 4D simulation to create the 4D simulation of an ongoing project work, which is for the tower A. And then after adding all the resources, labor and material cost included with each component, and then after doing the final EVM analysis, for which we can see the planned and actual data, we can also scan this and open a 5D model to run the perfect simulation, which we are unable to do so in this recording. But you can scan this and get the 5D model check, for which the planned value and unvalue graph we are getting for the different weeks from the week 1 to week 6. So this is the week 3, and in which we are getting the planned value as 76 lakhs 14,227, where earned value we are getting on this point is 66 lakhs 84,000 and 825 rupees. This is due to the construction work delays, which in week 2 we get the delay of 2 days because of the quarry strike, which affected the construction work delay, where the planned work we are getting seeing is the shuttering work is ongoing, where the actually the reinforcement work is ongoing on site due to 2 days of delay. The residential tower final 5D analysis of earned value graph. So we are getting the inference of analysis. The project is behind the schedule in week 2. As we have seen the earlier that SP we are getting is 0.591, only 59%. The planned work is completed, indicating the significant delay. By week 6, the SPI is moved to 0.86, yet the project is still lagged, achieving 86% of the scheduled work. And the trend suggests the partial recovery, but the highlights the ongoing delays. Despite of the improvement, project team may need to consider the additional corrective measures such as reallocating resources and optimizing task schedule, streamlining workflows. For the schedule variance, we are getting minus 30 lakh, 39 lakh, 10,931 rupees. For same, the cost variance we are getting is 1,82,954, which suggests project is under budget. And same for the schedule variance indicates the project is ahead of schedule, where the negative means project is behind the schedule. Same the SPI we are getting is 0.91, which is less than 1, which so completely showing that project is behind the schedule. And cost performance we are getting is 0.99, which suggests the project we are is showing that cost overruns are there. So let's come to the key learnings of the site layout optimization, 4D simulation, and 5D simulations. The beam supported path of travel analysis creates a more efficient site layout, reducing travel distance, improving productivity by enhancing material access. Same for the 4D simulations allows the phase by phase construction visualizations, improving planning, stage risk, and reducing risk of scheduling conflicts. 5D simulation offers the detailed cost tracking and forecasting, enhancing control over budget allocations, cost predictability, and throughout the project. This also site layout planning helps the better site layout, increasing projects productivity makes less cost overruns due to the well-planned site. EVM and cost calculations helps the tracking of projects and planned actual cost, tracking it using the last planner systems. So this is all the plumbing LOD 300 models. Projects for the project helps early crash detections and reduces the site non-conformances. Thank you.